Good morning, everyone. We will be starting the meeting, so please take your seats. Okay, good morning, everyone. Welcome to the third day of the conference. We have a very busy schedule this morning on the interoperability with other standards, and we will have 8 presenters presenting. Actually, we will have more than 8 presenters, but we will have 8 presentations. And we, as yesterday, are split into 2 parts. So we will now have the first 4 presentations as planned. And we will start with Marco and Laura presenting us elements related to the SDMX ontology. So, Marco, the floor is yours.
Good morning, everybody. I hope you had some space left after the dinner yesterday, because we're going to give you some food for thought. Another kind of food, but it could be filling. We hope it's nutritious anyway. So we are talking about this SDMX ontology work, which has already started, thanks to Laura, to Danny Gaffari from UNEP, and there is a task force ongoing, and we are going to report on the first results, asking also for possible volunteers and experts who might like to help us. So this would be very welcome. What I would like to say at the beginning, before giving the floor to Laura, who's chairing this task force, is that this work is, in a way, it follows a red thread from the beginning of SDMX. One of the first pilot projects I was mentioning on the first day was the metadata common vocabulary. And back in 2002, we were actually using this slide. We said it would be perfect if only people all over the world would try to understand each other. The problem is to get everyone to speak Norwegian, like we do. This is a slide we used in 2002 when we set up this project, Dennis Ward of OECD and I, to provide a common standard set of definitions of metadata terms. And for us, this standard language, of course, was not Norwegian, but it should have been SDMX. Now, what we are proposing now is a step forward. Let's say, after having a glossary of metadata terms, a simple glossary, the next step would be to create something still in the logical sense, but a more formal language, which is also able to provide relationships between the elements. So we're trying to move towards what is called an ontology. Some of you are very common with this term, others might not be. So first of all, I want to kindly ask Laura, what is an ontology exactly?
Yes, okay, thanks, Marco. So an ontology is an ancient word that came from 2 Greek words, ousia and logos, that is substantially the science of being. So an ontology is a way to represent the reality that can be a statistical domain or, in our case, SDMX. I know what you are thinking now, that we already have a language to represent SDMX. We have the information model that is represented through UML. But an ontology is much more than this, because it is much more expressive than another modeling language. So you can really represent the reality. And it's not all, because you can, the ontology can be translated into logical rules. And this gives you the possibility to query data using a language that is called a Sparkle language. It's a declarative language like more or less SQL, a little bit more complicated. But the important thing is that you can query using the semantic that you have used to define the ontology. And it's not only this, through these logical rules, you can also infer data. So you can discover knowledge from the knowledge that you already have. So it's very, very powerful. Of course, in order to query your data, you have to create a correspondence between the ontology and the data that you have. So this gives a lot of opportunities. First of all, the SDMX standard is more understandable because it's well represented. Second, of course, you can use in an architecture machine to machine. The most important thing is that you can query using a semantic, and when you map your ontology with the existing ontology that are related, for example, to SDMX or in general to statistical world, then you can query your data using other semantic. So this is a very added. Okay, this is the use case, no? You can, no? I think that you have missed the real use case. Okay, this is not important. You can go on the other. Okay, this is a use case. This is not a real use case, it's the architecture of a use case, but you can imagine, for example, to query the SDMX Global Registry without doing click or to follow the graphical user interface, or without to implement a complex SDMX query. Okay, then you can have an SDMX ontology, you can create a correspondence with your SDMX Global Registry, and this piece of software that is called the Reasoner transform the ontology in logical rules. And you can query your data semantically using the words that you use for SDMX. So for example, give me the codes of this code list and so on. So it's very interesting. And if you do a mapping, for example, as we did with SCOS, then you can query, for example, by showwalk, you can perform a query and retrieve data from the global registry. Okay. Okay, vabbè, fa niente. This is the task force. The objective of the task force were, first of all, define use case, understand better the context and the potentiality of the ontology. Then it was mandatory to reuse existing ontologies and, of course, implement an SDMX ontology. Okay. Sorry, Marco, can you go? This is what you have already said. Our task force has unlimited seats, so if you wanted to contribute, we are very glad, we are very happy to welcome you. Okay. So what we have done for until now, we have done a survey of the ontologies, and we have fit this ontology to SDMX building blocks, because ontologies can be specific for certain building block. For example, SCOS and XCOS map well the item scheme building block, while data cube vocabulary map better the data structure definition building block.
And there's also a problem of versioning there, because data cube vocabulary was elaborated based on SDMX 2.0. Now we are with SDMX 3.0, 3.1. So for those who are experts of the information model and the standards this tells you something, there should be also some work before doing this mapping.
Yes, the versioning is another issue. So, and also we have done a prioritization of SDMX. So we started by item scheme, category scheme, and so on. And to this block of SDMX, what we have done a mapping that is the most difficult part among the artifacts of existing ontologies and the SDMX artifacts. This is very difficult because you don't have a one-to-one correspondence usually. For example, Concept scheme is COS is a superclass of the concept scheme in SDMX because it includes also classification, list, and so on. So it's very difficult to semantically perform this mapping. Then, of course, we have implemented the SDMX ontology, we have implemented the mapping, and we also have tested using some tools that we have in use actually, to create a correspondence with the simple SDMX database in order to query and to test the ontology. And we have tried also to perform query using the other semantic, and it runs, so you can trust on me. It's a very good result. Okay, so the recurring action we will have also for the future, and we will apply to data structure definition, and we will map with data cube vocabulary and DCAT and StatDCAT ontologies. But the first point, it's very crucial. Marco, if you can click, sorry. It's a critical alert. We need absolutely to provide an assessment of what we have done, because the ontology grow exponentially, so it's better to have a clear basis on which to move on. So we would like to involve experts, both on ontology then on SDMX, to check our work.
And in particular, because in some cases we realize that there are some definitions which are not exactly the same between what is written in the information model, what is written in other parts of the standard, which is the XML documentation. So we wonder also what is the authoritative source for these terms in SDMX. So there is some issue to work on.
Okay. So the last, if you want, these are the useful links where you can to download what we have done, mapping, ontology, and so on. And if you wanted to reach us, you can write to Marco and me, and we will. Thank you.
Because some of the information is on GitHub, is restricted access, so we should give you access so that you can retrieve everything.
Thank you very much for the attention.
Thank you very much for your interesting presentation, and those who are interested to participate in the task force, please remember to talk with Laura and Marco during the coffee break. Now, going to the next presentation, unfortunately the colleagues with Indonesia are not with us physically in the room, but they will be connecting virtually to this meeting, so I hope the connection is working, and yes, we can see you on the screen now, so please feel free to start when you are ready. Okay, we can see the slides, but unfortunately we cannot hear anything at the moment.
Okay, good morning, ladies and gentlemen. Can you hear me?
Yes, we can hear you now.
Okay, thank you. Good morning. My name is Tri Listianindung. I'm from BPS, Statistics Indonesia. I'm sorry for not being with you all today. Today, on behalf of my team, me, Vincent, and David, I will present our experiences in building the statistical data standard, particularly how we combine statistical ontology with the SDMX charter. So, ladies and gentlemen, let me begin with the background. So there are two main backgrounds for our work. The first is the Law of Statistics, released in 1997. And the second one, the one is more recent, is the One Data Policy in Indonesia, which is released by the Presidential Decree number 39, 2019. And it is stated in the decree that to produce accurate, updated, integrated, and accountable data, it needs to fulfill four principles, namely data standards, metadata, data interoperability, and the use of reference codes. So the One Data policy is a mandate for BPS to develop the statistical data standard, or we can say it SDS, statistical data standard. And now what is SDS? SDS is basically a set of standardized concept, definition, classification, measurement, and unit of measurement to produce standardized statistical data. So when we design the SDS, we also get a reference from another best practice from another countries, namely, for example, from the Statistic New Zealand, and also from ABS, how they develop standard, and also from Statistics Center Abu Dhabi, and also from Palestinian Central Bureau of Statistics, or PCBS. But finally, our final structure is not replicate any of those model, but we have our own unique structure of SDS, which comply to the presidential decree with content of 5 components, namely concept, definition, classification, measurement, and unit of measure. So here, the first one is the concept. It is different with the concept we say in the SDMX because it refers to statistical term. So it represents the generic idea of a data, and then definition is a description about a data and also the scope and the boundaries of data. And then classification is a standardized disaggregation to present the data. And the other two is measurement and unit of measure. It is used for maintain the data comparability and interoperability. In constructing and implementing SDS, there are 3 roles that we define. Actually, it is also in the One Data policy. There are 3 roles. The first is the data producer, and data supervisory, and data trustee. The first one, data producer, is the units in the government institution that produce data. And then data supervisory is the unit that appointed to compile data and also to disseminate data. And the last one, data trustee, is BPS. So BPS serve as data trustee for statistical data, but for other data, it is another institution. And then for the process constructing NDS, the first one is during its formulation, each institution submits its own proposal of SDS draft for the data, and they submit it through the data supervisory to the BPS, and then BPS do the review and also compile and accepting the SDS proposal, which qualify, and then set it as SDSN, or we can say national SDS with that we set as a regulatory. And then once it's established, the SDSN or the national SDS, it is revert to all government institutions. So all of the statistical activity that is conducted by the government has to refer to SDS. And then the data is considered to be standardized when its metadata consistent with the SDS that is already implemented. And then after the data standardized, it will be easier to interoperate across all government institutions. So now what is the differences and the relation of the SDS and SDMX? The first one, SDS is used as a guideline for data producer on how the data should be produced, while the SDMX is used as a standard format for reporting and dissemination. And secondly, SDS focus more on consistency of concept and definition. So it's like semantic and also linguistic. But in the SDMX, it ensures the data structure consistency because of the standardized format. And the scope of use, SDS is used across government institutions in Indonesia, and SDMX used internationally. So actually, the integration of SDS and SDMX will amplify and enhance the impact of standardizing statistical data in data production process. And then how we further explain the relation about SDS and SDMX. The first concept and definition will be treated as reference metadata. And then classification in the SDS will refer to SDMX Global Registry if it exists. If it doesn't exist yet, BPS will create code lists corresponding to the existing classification. And then for disaggregation, it can use the code list combined with content constraint because in SDS, we only standardize the classification that meet some principle. For example, mutually exclusive and also exhaustive. And then the measurement and its unit will refer to SDMX code list as well, combined with the unit of multiplier. And then the overall SDS will be constructed as general DSD. And meanwhile, the content constraint formal data view will be created as data flow. And here is some practical example that we already implement in the SDS that refer to SDMX. In the slide, we see some of the classification that is also already standardized in SDS. For example, we also standardize the classification of sex, which also appear in the SDMX code list for sex. And in the SDMX, it is stated that the domain value is M and F. We also adopt the codification M and F in the SDS. But for the attribute, we use Indonesian language. And other classification that also in the SDS is classification for institutional sector and also marital status and degree of urbanization. And we see here, we have the codification for the SDS. It consists of number, and the first three number is referred to the CSA, classification of statistical activity. And in this slide, we see the data or indicators that appear in the SDGs CL series in the SDMX, and we also standardize it in SDS. We see it is just a few of the example. For example, we have here infant mortality rate with the CL series. This is the code, and we also standardize it in Indonesia, in bahasa Indonesia, angka kematian bayi, and it is completed with the international name infant mortality rate with the code for the SDS. In standardizing,
sorry
yes,
to interrupt
yeah.
you. Can I please ask you to accelerate and move to the conclusions because we are short on time?
Okay, thank you. This is the last example actually. So in the SDS, we standardize it by using it in a regulation. For example, here the components: name, concept, definition, classification, measurement, and unit of measure. And then our challenge and future development, for example, we have the challenge to determine the scope of data standardization and increasing awareness and participation in government agencies, and also increasing the completeness in SDS. And the future development, we see the possibility to set it as national registry and also fully implementing the DSD and also using the SDMX as a tool to implement in One Data Indonesia through consolidation of SDS and statistical metadata. Okay, thank you. That's for me. Thank you for your kind attention.
Thank you. Thank you very much for your very interesting presentation. And let's move immediately to the next presentation from Jan on the geospatial elements. Please go ahead.
Thank you so much, Marek, and good morning, colleagues. I'm Jan Burdziej, representing Frontier Data and Tech Unit from UNICEF's Data and Analytics. And my goal for today is actually twofold. First of all, I would really like to highlight the importance of geospatial dimension in our statistical data, but also I would like to share some of the work that our team at UNICEF has been working on into how to bridge the gap between geospatial and statistical data. So let me start with a hopefully not too controversial statement that spatial is kind of special, and I will share a couple of quick examples to back up this statement. Let me try to wake you up with a quick quiz. Does any one of you have any ideas of what these two numbers may be representing? Perfect. So you already see the, how powerful geography is, because by looking at two numbers, like many of you already were able to identify that these are actually geographical coordinates. And in fact, as many of you have mentioned, they actually point to the middle of our conference room. But we don't really need such a high precision, right? So let's just round up the number so it takes less space on the screen or in our database. So if we round up the value, well, our pin on the map actually moves 60 kilometers northwest and points into the field close to Ladispoli. But there are some more complexities. I don't know if all of you are aware, but actually there are hundreds of datums and coordinate systems. And what if these two numbers are actually coordinates in a local Rome Monte Mario coordinate system? Well, in that case, our pin would be pointing to a nice mountain range in Bulgaria, because this particular coordinate system is using different primary meridian. And of course, this is an edge case, right? But what about if someone just missed to add the hemisphere indicators, and these two numbers are in WGS84, which is the most commonly used coordinate system, but it's actually 42 south and 12 west. Well, now we are in the middle of Atlantic Ocean. So, and if you are saying that, well, these are really, it's not happening anymore, I can ensure you that this is actually happening. Before the UN, I've been working in the oil and gas industry, and we had a nice story about how an oil rig has been towed to a different side of the equator because of exactly the same mistake that someone has made. So going back to statistical data, so how the geospatial, why geospatial really matters when it comes to statistical data. And I would say there are a couple of things. So first of all, maps, and there is scientific evidence that maps helps people understand the data better. Maps help us overlay statistical data with other data sets like climate data, data on floods, earthquakes, whatever. But also maps helps us uncover spatial patterns, which otherwise without the map won't be easy to spot. So just look at the table that tells a story about the child exposure to droughts, and then look at the map. See how quickly we can grasp the situation just by looking at this image, right? And there is a saying that one image is worth 1,000 words, right? I would say a map is just a geo-referenced image, so probably even more than 1,000 words. And of course, also I wanted to mention, by having properly geospatially enabled statistical data, it also makes it more AI ready. So, I'm pretty sure that everyone has seen this map, right? So I would kind of argue that maybe even this is one of the most commonly accessed geospatial product. Actually, like a data-driven product, and which had like at some point more than 1 billion hits per day. So I hope that by now everyone is kind of convinced that spatial is important. So how this translates to our SDMX data? So what are the key challenges related to SDMX, to mapping SDMX data? Well, first is usually identifying the proper geometry, proper shape files, boundaries that our users can use to plot our data against. Then, even if we have the boundaries, we have to link the data to the boundaries. And as you can imagine, linking by names, it's very often tricky because of different spelling. And of course, if the boundaries are managed in different places than our statistical data, very often in many countries we have different codes. So then it becomes really, really challenging. And of course, there is another aspect. Usually maps allows us to show like one particular combination of all the dimensions that we have in the data. So there is this flattening of our multidimensional structures into more simplified data. And of course, time dimension adds another complexity. I will now give you a very quick tour of the two platforms that we've been working on at UNICEF, GeoCite and GeoRepo, and how they connect to SDMX Data Warehouse. So really, really quickly, GeoCite is an open source web mapping platform that is specifically designed to handle and visualize subnational country level indicator data. It's open source, and I will just give you a couple of screenshots just to give you a taste of how the platform looks like. Users can easily navigate across admin levels, across the time dimension, but also visualize data using different methods, also bringing and overlaying data from other sources like heat maps and so on. Also three-dimensional visualizations. Additional filtering, the ability to combine multiple indicators and identify hotspots on the maps, and so on. The second platform is called GeoRepo, and think about GeoRepo as like a dedicated, specialized geospatial code list manager. So with all the complexities behind geospatial data, GeoRepo helps us manage administrative boundaries which are versioned and are also exposed through APIs, including some of the dedicated geospatial formats like vector tiles. Imagine that at admin level 2 globally, we have more than 40,000 codes, entities, districts. So think about how your code lists would work with 40,000 records, and then add geometry for every single code. You can imagine how complex this is. And vector tiles are one of the solutions how to deal with this complex spatial data. So now it's the final piece, which is how we connect all these things together. And it's called the SDMX connector that we have built together with a bunch of brilliant students from the Harvard Tech for Social Good Society, where we basically embedded the SDMX data browser into our geospatial platform. And this is just a quick implementation, just a couple of screenshots where users, our GeoCite platform users, can browse through the agency data flow. They can even run scheduled jobs to sync the data, filter by different dimensions, and preview the data. And of course, the final result is the data can be easily visualized on the map. So by connecting our SDMX to GeoRepo, ensuring that our code lists have proper geometries managed in GeoRepo, and by connecting the GeoCite with SDMX, we can now easily bring all these data sets together. And in terms of next steps, I mean, this is just the first version. We have some plans for making it even more robust. So we are considering this pub-sub data syncing mechanism, implementing this mechanism, but also thinking about like real-time live SDMX data visualization. And of course, we want to keep producing more and more subnationally geocoded indicators. So some key takeaways. First of all, if you are interested in any of those platform solutions, GeoRepo, GeoCite, the connector, please feel free to reach out to us, and we will be more than happy to talk and explain in more details. And some like more high-level takeaways. I really believe that geospatial dimensions add a lot of value to our statistical data, and sharing ref area codes is not enough for our users to be able to utilize the data efficiently. We have to make sure that users can access actual geometries, boundaries. And you're not alone. There is a dedicated expert group on bridging these two different things together, two aspects together, working under a committee of experts on the global geospatial information management under UNSD. And for those of you who are actually managing SDMX data sets, data registries, think about these two questions. how many of your end users may actually want to map your data, and as of now, how difficult it would be for them to actually make it happen. With that, thank you so much, and over to you, Mark.
Thank you very much for your very interesting presentation. The geospatial data are very interesting, and I am sure we can spend a full day on it, but unfortunately we don't have time, as my colleagues Antonio and Daniel are waiting with their presentation.
Yeah, thank you very much, Marek. And we already had a geography quiz today, so let's make a very short metadata quiz to keep our brains going. So what's the coolest metadata standard in the world? Let me look into the room. Yeah, most of you know the answer, but unfortunately we are not alone. So in some other rooms we get different answers. So what me and Antonio were trying to do now in the next 8 minutes is to show you a bit an approach to integrate with the data point model standard, which is coming from the supervisory world. And just to start, I will start with lining out a short business case from the ECB perspective of why we think it's important. Also why we believe that hostile takeover of other standards is not our business. It is to work with other communities together, and we see a possibility to do so. So why would we do that? In the ECB and in many other central banks, supervisory agencies, we have the challenge that we need to combine regulatory data, regulatory reporting, supervisory financial data with statistics. And many organizations have both of these branches, or some need at least to work nationally together on this data. We have different starting points, of course. So regulatory reporting looks at financial supervision, risk assessment of the financial sector. We have regulators, we have authorities with the scope of financial data. Like in the ECB, in many cases, statistics is in the same institution, sometimes it's not. But our mission is, of course, to have good quality, transparent data for society. And then the audience is policymakers, is the public. So we have a different scope on what do we do with the data. And also a different scope on what data, because statistics, of course, looks at everything. But many cases you need to combine it then with financial data. For instance, you look at climate risk or green investment, you need to have geographic data available, you need to have certain trends available, plus you need to combine it with financial data. So what is in the middle? In the middle we have data management and we have business processes that manage data, and suddenly when you go into that layer, it doesn't look so different anymore. We need to describe and model the data, we need to collect and validate it, we compile, produce, very important, integrate, which I think is a big challenge now. We heard very often with AI about data integration. How can we automate that? And then at the end of the day, disseminate it, analyze it, make our conclusions, and it starts again from the beginning. So if we look at the process, it's not so different. When we look at how the process is worked at, it's very different. And we have the challenge now to combine it. And as ECB, of course, we have the challenge even more because we have this double mandate in the institution. Fortunately, Antonio is here to rescue us, and he will show a bit on how these two worlds can work together, and that we have opportunity for solving this big question tag in the middle. So Antonio, the floor is yours.
Thank you, Daniel. Well, I think that a very obvious question comes to mind, which is if we have two standards for solving the same issue, right, the same business process, why? Is there a good reason for this? I have been working for many years on both fields, and my answer is a personal answer, of course, but is for historical reasons only, which is relevant, of course, right? But the reason is that there are different practices. If you look at the regulatory reporting, normally it is the supervisors defining the data sets. And they are used to seeing forms like the balance sheets and the profit and loss statements and all these kind of things that have been the same for a couple of 100 years, right? This is what they are used to, and this is what they are thinking of. While if you go to the official statistics, I guess you will all be familiar with the data structures and this kind of thinking. This leads to people defining things in different ways. So a supervisor, as I'm going to show you later, will start thinking of the table, and then the rest will come, while the statistician will start thinking about the data structure definition, right? And also, for me, I like to see this as multidimensional data only. But it is true that in both worlds there is more specific views, right? Like subtypes of multidimensional data. Statistical data, there is a lot still of time series based, time series focus, right? And when we go to the regulatory reporting, there is a lot of focus on one unit, so one bank on one date, right? So these are different practices, but fortunately there is some common ground. Everybody realized that the glossaries, intended as the concept plus the code list, basically, is very relevant, and providing a dimensional definition of the datasets is very relevant. So with the next slides, I'm going to try very quickly to give you an overlook of what DPM looks like. This is an SDMX conference, right? So the idea is that you have a bit of knowledge of SDMX, right? And from there, I want to show you what would be the DPM equivalence. This is something that, okay, this is a snapshot yet from FMR, right? This is a data flow we took from Eurostat. We modified it slightly, but this is something that most of you will be able to recognize easily. To summarize it, some data points could look like this, right? So we have some demographic data broken down by age, sex, geographical area, and we have 3 measures: population, number of deaths, and number of births. I think that is clear for all of you, right? How would this look like in the data point model? By the way, it's also related to XBRL, okay? But just to focus a bit, to narrow the problem, let's talk only about the DPM. So a supervisor would start by designing the table, right? So how do I want to see this in the form of a table? There are many different ways to draw the same data when you start drawing a table, right? This is just one example where we are having some rows and some columns. This is what is called headers, right? In this case, I have decided to draw this like we have rows with the breakdown of countries and age, and we have column with the metrics and with the sex, okay? The Cartesian product of the rows and the columns is the cells. For each row and column, we can have some labels and some codes, and also it is important to note that some cells may not be applicable. For instance, in this case, we have a number of births. I guess that the age buckets do not apply here. The second phase is, okay, now we know it's important to provide some modeling, so what the supervisors are doing in this case, or some modelers with the supervisors, are providing some dimensional definition. So for instance, for row 30, they say this is age, this is a bucket between 25 and 74, and this is for Belgium, right? And for column 90, what we have is the metric population for males, okay? Then note that in this case, the time period is implicit. Of course, there is a time period here, but in the DPM, because they are used to seeing this kind of tables, it's implicit. They are not defining it. It's a common practice, right? It's not necessary, but it is like that. Once we have this, we can do again the Cartesian product of all the modeling, right? So that, for instance, if we focus on this cell, that is the the row 30 and the column 90, we can create a variable that in the end is composed of what it's called a context, okay? That means that it's for this age bucket between 25 and 74, for Belgium and for males. And we always need to have a main property that would be like the metric, like the measure, right? Which in this case is the population, okay? If you see now, we have reached the dimensional definition that, and if you see, it's in the end is equivalent to what we have in SDMX. Because if we look at this with data, right? This is exactly the same data points I was showing you in the beginning, but in this case, they are rendered in this table. So if we go back to this row 30 and column 90, we are going to find here a figure, a fact, right? And we have 3 different ways to see this, 3 different ways to refer to this. One is the table row column. So this is this table with the row 30 and the column 90. Another one is the variable, right? This is variable 223. But because the variable contains all the modeling, I can say that this is the age between 25 and 74 for males for Belgium. And this is strictly equivalent to what we are going to find in SDMX.
Yeah, so basically, what is our objective? Our objective is that we have, of course, we need to be able to consume data. I mean, not only from DPM world, but from many other worlds as well. You will all have your own challenges. What we want to reach is that we started already doing some mapping of terminology. You cannot imagine how difficult it is if you talk to somebody about the concept scheme and they will look at you with puzzled eyes, or even when you talk about the DSD. We had even a code list is not called code list in the TPM world, so it starts already with very basic terminology to understand each other. Then to try mapping the standards, we have done some work there as well by now, but we need to go further to say how can we converge that we are able to treat all the data, that we are able to consume all the data, and that we can use the strength, let's say, in a kind of best of both worlds scenarios, how we can combine some strength of TPM it has for easy understandability for a supervisor with the strength SDMX has, for instance, to have a good API, to have a good community and so on. We all know those, right? So what we are looking for is how can we manage the metadata in a kind of standard independent way, but then utilizing the standards that we all love. Thank you.
Thank you very much, and thanks to all presenters in the first half of the session. We are very short on time, but we still have a time for one question or maybe even two very short questions. So I see two hands, one there, so please go ahead.
Laura, just a moment. Yes. RDF Data Cube and DCAT. I suppose that you have already known that some experiment and also some study was done in the past concerning the DCAT, StatDCAT, and RDF Data Cube directly in ISTAT. I mean, for those of you that are using for example, the NSI web service of Eurostat of the reference infrastructure, the SDMX API, it is free already a plugin developed by ISTAT where you query using the SDMX grammar, but you can extract, negotiating the format, the RDF XML data cube format. So it means that this kind of mapping was done. And you can extract both in RDF data cube structure metadata and data. Also because the RDF data cube has most of you, or some of you knows, is based on the SDMX information model. So it is very easy to make this mapping. The second part concerning the DCAT, also in ISTAT, we presented several times that metadata structure definitions is, with the metadata structure definition, is to map a DCAT application profile. And we mapped the DCAT application profile for Italy. So, but using simple metadata structure definition. And we, let's say, took in consideration when we mapped this, the study that was conducted on StatDCAT. This is just to inform you to not repeat things that we have done in the past. This is the first question. The second question concerning...
Okay, I'm sorry. It was already a very, very long question. You can take the second question during the coffee break. I don't know if Laura or Marco wants to react very briefly now or during the coffee break. Or...
Yes. Thanks, Francesco. As you have seen in the timeline, the next step is really the data structure definition, and then after the metadata structure definition. So we are very happy to use the mapping that you have already done. This is very, very helpful for us. Thank you very much.
Okay, and we had also one head here, but please, very, very short question if possible.
Nicoluccius from the BIS. The question is for Jan on the geospatial presentation. I'm not sure I understood if you were using already the SDMX geo code list features. That was the question, and if you plan to do. Thanks.
Yes, great question. Thank you so much. So no, we are not using this feature from the latest version of SDMX. We are looking into that, and I'm looking forward to the capacity training for the next 2 days to learn more. Thank you.
Okay, thank you very much. So now I will ask for a change of presenters. Let's hope we have enough places here. So we have managed the transition very swiftly and very quickly, and let's go immediately to the first presentation on a VTL desktop for CASD. So please.
Okay, can you hear me? Yes, okay, thank you, Chairman. Thank you very much. I'm Kamel Gadouche, I'm the director of CASD. So CASD is a non-for-profit public body as a consortium gathering the French National Statistical Institute, INSEE, and Banque de France and universities. So its core mission is to provide secure environments for processing confidential microdata. So I have to move, okay. And first, which data? So it's raw data, confidential data, raw data from data producer such as, of course, the French National Statistical Institute, Banque de France, ministries of health, finance, for tax data, labor, and also from banking data and from private companies such as Meta, Facebook and Instagram data, and TikTok and so on and so on. So very sensitive data. Second, it has, of course, to be very secure. So we are certified ISO 27001 for security. And we also, we are the first data hosting service certified officially from the GDPR, Article 42, via the Euro Privacy Scheme. So very detailed data. And we provide access to 2,000 active users, 1,600 are researchers, as you can see on the left, and 400 are data managers, data scientists from institutions. And those data managers produces data sets for all the external users. So among them, one is IRDES, which stands for Institute for Research and Information in Health Economics. And they are our clients, so they came to me because they wanted to live, they have to prepare and manage, create new data sets from administrative data, and they are used to use the SAS software, and they want to leave SAS, and they try to do the management with R, but they had many memory issues. So I asked them a use case. So the use case is for big data sets of 166 million records of health services. They wanted to transform the data sets, to prepare the data sets, so they do data preparation, and they also have to apply filters and aggregate by patient and quarter, and then pivot by quarters the data sets. So that is the use case, and the challenge was to find another tool to do these operations. And I asked them their expectations. So for their expectations, they also, as it was mentioned many times yesterday, they wanted a user-friendly tool, and so that they can visualize the data sets, the input data set, the intermediary data sets, and of course the result data sets. They want to manage data sources in folders and or buckets. Of course, they ask for performances because they had many memory issues with R for put all the data in memory. So that was the big expectations. But they also were interested in the documentation and using a standard, international standard for documented the lineage. So what did we do? So we started to looking for a tool for that. And I had a talk with Franck Coton, who's here, and Nicolas Laval from Making Sense. And they told me that VTL could be a very good client, and they were working on open source VTL engine for this. So I give the floor to Nicolas from Making Sense.
Thank you, Kamel. Is good? Okay. I'm not sure. Doesn't matter. So you have here the... Okay, thank you, Raphael. You have here the functional architecture of the solution we build with CISD. So you have at the right the UI, which is a kind of friendly UI, modern in React, and that's the whole part the business user will see. All the other pieces are under the hood, are technical pieces to perform big calculations. We have the possibility in the application to read datasets. We support several formats, which are listed there. And we missed to mention SDMX, because CISD doesn't use SDMX, but we also have the possibility to read metadata in the registry, provide location, and run scripts on SDMX sources. And at this point, we use the implementation of SDMX core from BIS, which is a really nice use case of reuse. How do we perform calculation? We do that through an API in Java. We have way, the way to work is with Q, because calculations are sometimes a bit long. We use Treva's VTL engine, and we perform calculation as distributed computation thanks to Apache Spark. I have just one focus on the two tools we maintain as open source at Making Sense. Up on the other slide. And in the UI, oh. Okay. In the UI, you have the VTL editor, which is a React component available directly on NPM. And we have so the engine, the name is Trevas, and the main implementation is in Spark, so you are able to distribute it your computation. We also use some other powerful framework, such as DuckDB, to read database in an efficient way. And I think it's good for architecture. And now it's demo time. So you can see the home page of the application. The home page enables the user to manage projects, so create a new one, importing existing, having some favorites, and so on. When you go in the IRDES sample, you discover the project page with the editor and the script for IRDES. At the right, you have the data spaces to link data to the script with a dedicated notation, dataspace.tablename. In a data spaces, you discover your table on your file systems. You can open them. You can discover. In a new feature, you will be able to filter, to do some nice things with the UI. You can also play and reorganize your layout if needed. And as I have VTL script and data sources, I can now run my VTL transformation. Before that, I run a preview phase, a kind of semantic validation. My preview is good, so I have a tab to discover step by step, in an accuracy way, the state of my metadata. For instance, I have a table with 6 variables at this time of the calculation. And I can also have a view, which is a bit strong for this use case, because a lot of variables, but it's a lineage one. So we transform the execution in a documentation with lineage. As the preview is good, I'm ready now to fire the real execution in the distributed environment. So you can discover the script, and we will have, so transformation is done, logs told me that dataset has been written, and I focus in the term data space on liquid GP table, which is unpivoted. And as you will see, the last instruction of the script is just to pivot this table to have a statistical friendly table. So I go to the output data space and I discover my table, which is persisted and pivoted. That's it. I think we answer to the use case of the researcher, so we can give him the new table.
So thank you very much, Nicolas, for the conclusion. As you can see, everything is checked with this tool. It's still in progress, but for the ergonomics, you could see the visualization, and also for the performance, you were able to see that we used the Spark engine, and for the documentation, the lineage, and so on. Just to conclude, that we have a stand, and don't hesitate to visit us in our stand here just in the lobby. Thank you very much.
Thank you very much for this very interesting presentation. I can only say that I wish the tools I have at my disposal were as fast and responsive as the demonstration of your tool that you have shown. But okay, let's now go to the colleagues from the Statistics Estonia. Veiko, please, the floor is yours.
Hello, I'm Veiko Bertsen from Statistics Estonia. We have a mandate to coordinate data governance in Estonia. And for that, we have done it for 5 years now, and we have some achievements and some problems. And I will more tell about the problems than achievements. Basically, we have some 300 official registers. We have 24 or something like this agencies, and 7 IT agencies in Estonia, 11 ministries and others. And we have there in these 300 registers, or their number is approximate, we have more than 1,000 e-services. You know, Estonia is famous for its e-services and digitalization, but still, what we lack, we had this system in place for more than 15 years now, even 20 years, but what we lack is the good semantics. And therefore, we took approach that we need something which is making data better understandable to our agencies. And our business case is, as you read there, that we need some better secondary use of data, both the sort of the primary, or we call it microdata, but for the administrative activities, and also for the analysis and statistics. We took approach that we are creating the data catalogs. And of course, there are different types of data catalogs, but this is not the technical data catalog only, but this is also a technical one, directly scanning the physical databases. But also, we are currently creating data dictionaries and business vocabularies on the top of these physical databases. And for 2 or 3 years ago, we decided, not we, but the ministry decided that we will link two things together. One is the Register of Registers, or as it's called here, State Data Catalog, and another approach, which is European one, the Open Data Portal. They were separate, but now they are linked. And of course, tremendous problems comes from it, because one is from the physical data databases or registers, and other is open data part of it. And we also want to link it to our product, which is data sharing service. According to the Data Governance Act, we can provide it, microdata service for the scientists and analysts. And the data portal is in place. We have different standards there. This is the problem, and therefore I'm speaking here. Open Data Portal its use is the dataset level description, DCAT, and we have also a little bit like our application profile. We have data dictionaries and business vocabularies linked with this. And the problems comes that different TCAT profiles like health TCAT, mobility TCAT, and others, also the stat TCAT, which is a question, is coming in from the data spaces movement, and approach is to publish all these in this centralized Estonian data portal, this one. And there is open data and administrative data together. We use, in Statistics Estonia metadata platform, we use Collectica, and Collectica, we have variable level description. In this open data portal, there is a limited variable level description. This is a problem, and the dataset level description we have also. And we also have a service to this data sharing service for research and for research, and we are mirroring the metadata to this portal, and this metadata is more or less a DDI standard, but of course there is a question about what is the data, sort of ontological questions, what is the data set and what is the distribution, which is the DCAT object. What we need is, I don't know, another standard or some kind of standardization. Perhaps you will talk about it a little bit later. The screen went black. Oh yeah, it's came back. Okay, and stat TCAT is in place, but by as much as my understanding is, it's more or less in some kind of shadow or half dead, or I don't know. Perhaps somebody can tell me. But what we need is something which will allow in the larger framework, as much as I understand of this data spaces movement and TCAT application profiles, to agree what kind of standard or standards or interoperability possibilities will be between these standards which are already in place. Not creating new one, but just implement something. And we are currently using, as I said, DDI life cycle, which is good, but there are some problems of it, and I will come to this in the moment. And a new one, CDI is coming in. We are not using it, and we use a little bit. It's not our practice to use SDMX, but we are of course sending the data sets to the other officials by using SDMX also. And this DDI CDI is a new thing, and there is a object or ontological object or description object called dataset. And what is good, by my mind, to solve our problem from the official registers towards the multidimensional datasets is that there are dataset types, and dataset types we need to describe different dataset types into our Estonian data portal. And administrative datasets there are 4 of them: long, wide, key value, and dimensional. And administrative registers are more long, wide, and key value ones. More are long, and this is a problem we can describe from in the statistics and analysis where the wide and dimensional. But there are also another open data sets, other types, not the type of this kind of data, but the videos and things like this, and to send these to the European data portal. And basically, this is the problem. This is the business problem we have. We need to solve it, and I hope Matthias and others will help me. Thank you very much.
Thank you. Thank you very much for your presentation of the issues in Statistics Estonia. It's very interesting to see the issues you are facing. But now let's go across the ocean to Canada, and Flavio should present. Yes.
Matthias.
Matthias. Sorry. I have a wrong name here. Then sorry for that.
Yeah, no problem. Yeah, thank you, Marek. In reality, it was supposed to be Flavio presenting this, so I jumped in because he unfortunately cannot be here. But basically, it is a work of the UNECE Supporting Standards group that I'm also a member as well as I think quite a number of you here. In the Supporting Standards UNECE, we develop and support conceptual standards such as GSBPM and GSIM, but in the last years there was a lot of discussion about interoperability, in particular interoperability between standards. We have a working group for that purpose, and I'm present this here. But first thing, I am very glad about the order of those presentations, because all the difficult abbreviations that I plan to use here have been already explained by my colleagues. So hopefully this will make it a bit easier to understand. First thing, we wanted two things with our approach. First is to be practical, so not to have very theoretical models, even though that I will show one, but to be able to provide some guidelines or some support that can work in practice. And the second thing is to limit the scope, because interoperability between standards can go widely in different directions. So we focused on another priority from the UNECE modern stats community, which is data integration. Here is the definition of data integration, what it is, but we focused on some existing use cases which are in existing practical implementation projects already happening, and I will just mention three categories. So first is UNSD, SDGs, SDMX data mapping to Google Commons. I don't think that I need to explain why is this useful, because on Monday there was already discussion, including with a colleague from Google about that. About that project. The second example is that there is a data catalog with the health data, so health domain, International Health Surveys Network, I think. Yeah. Household survey. Oh, household survey. Yeah. The household survey, which has already a lot of studies documented in the DDI codebook, but would like to be published via SDMX. That's example how two standards could be used in the same pipeline. And the third one is there are a lot of real cross-domain projects as part of World Fair initiative, and there is cross-domain interoperability framework where there are more use cases like that. So in terms of mapping approach, you have probably noticed that DDI CDI abbreviation comes in many of those examples because projects have already using that standard. And I think this is about we shouldn't invent another, standard number 15 to do the mapping if something already exists. So we look at that, and DDI that you explained already what it is. DDI CDI can come handy as a kind of Rosetta Stone. At the beginning we used the term converter, but after looking at it we realized, this is not as simple as just plug in like a different type of electricity outlet. Yeah, Rosetta Stone is the term that we used. And yeah, it has several benefits or features. So it is multidisciplinary already. It actually decouples how the data is represented, like multidimensional, white, rectangular, etc., from the conceptual information model of the data, and already integrates with DDI, other DDI standards. To do the effective data integration, we need to define mappings between the important classes or concepts in those standards that we use, and if needed, harmonize them or explain the differences, and then preserve the process metadata that it's clear what has been done with the data during the data integration. So the ultimate vision here is to be able to build interoperable pipelines. So here we are using GSBPM and GSIM as a kind of generalization, but in any of these phases, like GSIM could be SDMX or could be DDI. So to be able to do some sort of mix and match and still preserve the structural and reference metadata to the next phase. So that's the idea, and of course the focus is on SDMX and DDI. Then in terms of benefits of this approach, so if we manage to do that, we can already cover quite a number of very popular standards like a DDI codebook, DDI lifecycle, CDI, of course, SDMX 2, 3, as well as certain ontology type standards like XCOS for statistical classifications, NVTL. And we can also use the tools that are already available. And these standards already have some support for harmonization. However, there are some issues. DDI and SDMX have been developed separately for very different purposes initially. There are challenging terminological as well as kind of conceptual differences. Yeah, they have different strengths and weaknesses. So I will show you this on a simple example. So far, within the modernization group, we already delivered the document which identify relevant SDMX and DDI artifacts for GSBPM subprocesses. So that document has been published. But at the moment, this is a little bit not correct. So we are still in the process of developing guidelines how to make those standards to interoperate and building those interoperable data production pipeline. And then in the future, we could include some extensions to XCOS and stuff like that. Just to give you a little bit of insight how complex that can be is, so you have on your right side in yellow, there are CDI, DDI classes, and on the left side in blue, of course, is SDMX classes. And if we start at the top and we say, oh, okay, let's compare concept class, we can see that even concept class in SDMX is not the same as concept class in DDI. Yeah, in SDMX is more narrowly defined, usually means variable. In the DDI, it's much more broadly defined, can have hierarchies of all sorts of concepts. So yeah, mappings are many to one or many to many. We can still map combinations, but there is a tendency that they can be also use case or category of use cases dependent, because it also depends how people who produce these DDI SDMX artifacts actually model the data and stuff like that. So that's just a challenge. Yeah, you can look at this offline In terms of the final slide, expected outputs, idea is to publish guidelines that will not be prescriptive because we cannot do that, and identify data description elements from both DDI and CDI that are important to be considered when we do such a data integration and mappings and etc. Another thing that was already mentioned also a couple of times is confusing terminology. So yeah, the glossary with describing those differences would be really useful, and I think we can work on that together with some other activities. And then in the future we can have focus also on other standards that are for which we can reuse similar approach. That's it. Thank you, and yeah, look forward for questions.
Thank you very much for this interesting presentation. And now we move to the final presentation in this session to Konstantin, Yuri, and Elena.
Oh, sorry. To giving us to, okay. The opportunity to share, what, please. Thank you for your giving us the opportunity to share with you the approach to semantic transformation of SDMX that we are developing in the CIS Stat Committee as part of our work in linked open statistics. For 3 last years, the CIS Stat Committee has been applying the FIRE principles in the dissemination of linked statistical data. To support this effort, we have created 2 key systems: semantic knowledge management thank you very much, system, and loss preparation and dissemination system. They part of our data hub. These systems ensure both the publication of semantically enriched linked data and metadata and creation of a semantically rich environment of for interpretation. This is very important for improving the quality of statistical data and metadata, harmonizing terminology, aligning methodology and classification, and of course, the ensuring semantic interoperability. We have already covered 15 statistical domains. For the first time in the CIS country, more than 350 lots data sets with rich semantics have been prepared for more than 100 statistical indicators. To achieve these results, we organized collaboration between statisticians and IT specialists. In total, more than 500 documents and 300 terms are used to build a semantically rich environment for interpretation. To create loss, we rely on international standards and specifications. SDMX provides the context and terminology for data exchange and shared code lists, and RDF data queue vocabulary gives us a specification and a set of models to support rich semantics. Each information model is based directly on the SDMX information model. Here, the semantic knowledge management system plays a central role in ensuring meaningful semantics across statistical domains. However, in practice of using RDF data queue vocabulary, we have faced several challenges. The outdated SDMX model from 2009, the lack of namespace support since 2013, 13. Non-compliance with best practices for persistence URIs, and a rather limited set of semantic models, not sufficient for building our lots. That's why we started our work with the international non-profit initiative, Interoperability Basis, organized by our Slovenian colleagues. It has helped us significantly advance in solving the problem of ensuring a rich semantic for the formation of lots datasets. Please, you.
Thank you, Konstantin. Opening semantic horizons to SDMX, we loaded into our interoperability basis platform 3 latest SDMX documentation versions, a glossary and code list from a global registry. Using the platform pipeline, we made semantic transformation, alignment, and enrichment of SDMX components, created semantic models, and assigned persistent URIs in a managed namespace. As a result, we provide enhanced capabilities for discovering SDMX context and for interactive exploration via linked elements of the standard. It helps user to trace links, to understand the standard deeply, and to analyze how terms are used in different versions of SDMX. The referencing of persistent URIs in accordance with semantic web rules represents terminology both for humans and machines. For glossary assessment, we offer analytical tables and glossary control to detect cyclic definitions. Visual tools make the work with many thousands of codes clear and efficient. So we successfully launched the first semantic SDMX, and it is really ready for further alignment and enrichment. We have also started SDMX localization with Serbian Statistical Office and prepared a managed codes namespace for a smooth implementation of SDMX into linked open statistical datasets.
So I continue from the part of CIS Stat Committee, and we are already using the benefits of the platform Yuri has presented just now to enrich our classifications with provided semantic links to SDMX code lists in our semantically enriched statistical indicators descriptions and in linked open statistical data sets supported with SMART, we mean semantically enriched metadata. At the same time, together with our Slovenian colleagues, we have identified a range of gaps and issues in SDMX documentation and in the process of its implementation. Among them are missing links between related code lists, and here you see some examples. Lack of descriptions, purposes, and sources for code lists. Limited glossary semantics. The glossary only uses just one attribute, related terms. Inconsistent source reference, so we never get the correct version of the source of the description of the glossary term. We found also semantic loops in concept definitions, so some concepts are defined through others, requiring expert correction to resolve circular references. So, and some terms are actually not used at all. Looking ahead, we see strong prospects for collaboration and advancing semantic interoperability in SDMX and improving the standard itself. And as we saw the first day at the conference, making SDMX AI ready is now in the spotlight. And we are convinced that the real and the strength path to achieving this lies through rich semantics. And we will be glad to show more detailedly our solutions via webinars. And so let me thank Laura for interesting news about SDMX ontology. And so we are really ready to contribute because we have a lot of things to share with you. So thank you very much.
Thanks very much from the colleagues from CIS for their presentation, as well as all other presenters for keeping the time very well in their presentations. Now the most difficult task is how to balance the need of people to ask questions with the need of people for a coffee. So I think we have time for 1 or 2 questions that will eat 1 or 2, maybe 5 minutes from the coffee break. So are there any questions? I can see 1 question on my left and no hands on the right or in the middle. So we will go with the colleagues on the left.
Hello, I'm Frank Coton from Making Sense. It's not much more a question, but a point of information. I already sent Marco and Laura a mail about this, but since it also resonates with the presentation from Vaiko and from Matthias, I make it loud. There is currently activity in the W3C for drafting a new lifespan for a working group on dataset exchange on the web and the maintenance of DataCube and DCAT and other things related to all we said this morning are explicitly in the scope of this working group. So that's a point of information. I happen to co-chair this group. So if you want information, just come to me and we'll see how to interact.
That's very good because actually I'm not going to ask myself a question. I would have the answer maybe, but I'm going to ask to Matthias, to Frank, why not Edgardo and other experts this question. Are you aware that we are talking about a series of standards in a series of versions? So in a way, there are also several potential ontologies, and the problem of mapping all of these. And are you aware that the ontology that we were proposing and others proposing are more at the meta model level? We have the data, then we have the data model, and then we have the meta model to which data model conforms. So when Laura and I were describing the SDMX ontology, we're working at the meta model level, but there are other possible glossaries and ontologies at the level of the concept describing the DSD in a certain domain, national accounts, balance of payments, labor force, and whatever. So we have a family of glossaries, and linked to this, we have a family of ontologies. So I don't know how many groups are there describing this and that ontology. I'm happy for Frank's information. This is very valuable. I don't know if at the end we will need to form somewhere. I don't know where is the place. Maybe not this one, but maybe at the higher level. A group coordinating all these works together, because one work depends on the work that you're doing in another place with another standard. So are we aware of this?
Okay, thank you very much for these questions and comments.
I want to make a comment on this. We're totally aware about these problems, of course, but what we are trying to avoid is to be so metaphysical and to create upper ontologies, middle ontologies, and so on and so forth. we have a mandate to be practical also. Of course, I understand this, and as you remember, George Ulrich in the first said that there are some kind of debate in the society as a whole. He mentioned the Habermas approach and critical thinking of the 60s. This was that the words are not important, the use is important, but for us, some kind of metaphysics, by my mind, is important. But where is the right level of to be metaphysical and to be practical? This is the problem.
Yeah, I would just like to add, yeah, I completely agree that this is very complex landscape. And in terms of coordination, concretely for supporting standards group, so we are coordinating work also with the TWG, which also has the, SDMX TWG, which has the work stream on interoperability. So we are going to try to kind of leverage, each other's work and don't overlap, etc. And any other initiatives that we are aware. That's one thing. The second thing is, I think besides that people need to do their task and be practical, is that there are a lot of standards that are designed for specific purposes, and I think we have to live with that because they are really good at what they do. And some standards we can keep extending, like we have been doing this with DDI, with SDMX, to new areas, which is good. But there will always be, multiple standards, and both within statistical community as well as on the, generally. So we need to keep up with that. Thank you.
Okay, can somebody please bring microphone to Edgardos? Thank you.
Just to complement what Matthias was saying, we are so aware in the interoperability group of this complexity that Marco was talking about, that we decided not to write a general guideline on how to map SDMX to DDI CDI. Not even in this particular case, we think that we are able to have a general guideline. So we decided to work on specific use cases and prepare guidelines as examples that maybe in the future can be generalized. But we realized that it's so vague that it would be impossible in a, let's say, reasonable timeline to have results if we want to create the general manual on interoperability between SDMX and DDI CDI. So if you extend that to multiple standards, imagine what that would be.
Thank you. Thank you very much for this additional information. So now we will have a coffee break until 11 o'clock. So please come back at 11 o'clock for session 7 on upgrading the standard. Thank you.